So I had a chat with one of my students who said that he prefers listing the multiples of the respective numbers before he can find the LCM. And of course, while that is okay for some numbers, for example, the first one, 10, 15, and 30, if we were to find the LCM of 10, 15, and 30, you can easily just list the multiples, right? So for 10, you want to list the multiples. You are going to write what? 10, all right? And then what's the next multiple of 10? You have 20. Just keep multiply by counting numbers. 1, 2, 3. So you have 30, you have 40. Let's stop at 50. What about 15? The multiples of 15, let's go. 15. What's the next one? 30. We can already see that there's a common multiple here. Let's try the last one, 30. What's the common multiple? 30. Now, why this is very cool and easy for us to identify the common multiple. But the problem now comes if you have a question where you are asked to find the LCM of 25, 36, and 54. So you see where this can have its limit. Anyways, let us see what we can do with the second question, where we have 25, 36, and what? 54. So if you are to list the multiples of 25, you have 25. Next one is what? 50, 75, 100, and so on and so forth. What about 36? 36, 72, 108, yeah? What about 54? You have 54. What's the next multiple? You multiply by 2, you get what? 108. Now, before you can get a common multiple, the lowest common multiple of 25, 36, and 54, you would have listed so many multiples. So you see where this has its limit. It's okay for numbers like this, but for numbers like this, do not try to list the multiples. It will wear you out. So what should you do? You can use prime factorization or the popular tabular method. Let me show you what we can do. Let's quickly use prime factorization. Okay, so I'm going to start with 25. If you break this down, you have what? 5 times 5 is already 25. So we're through with that, with this first one. What about 36? We'll break it down. 2 times 18 will give you what? 36. Break 18 down, you have 2 times what? 9. And what about 9? You have 3 times 3. So it means that 3 times 3 times 2 times 2 will give you 36. And what about the last one? 54. Let's try 54. You break it down, you have 2 times what? 27. What can divide 27? Prime factors now. We have 3 times what? 9. What about 9? You have 3 times 3. So when you bring out everything, these are the prime factors multiplied together to give you what? 54. Hey friends, do you want structured, detailed, and easy to follow math lesson? Join GPAD Maths Academy, link in bio. Now I want us to write everything in index form, and I'll show you what we can do from there real quick. So let me start from 25. 25 is what? 5 times 5. And if you write it in index form, you have what? 5 raised to the power of 2. What about 36? That will be what? 2 times 2 times, that's 2 raised to the power 2 times 3 raised to the power 2. And then the last one, 54 is what? 2 raised to the power, that's 1 there, times what? 3 raised to the power 3. Now, like I said, there's also the tabular method you can use, which to me, I even think it's easier compared to what I'm doing now. But I just want to also show you how to use this method to find the LCM of these kind of numbers. So let's go now. For LCM, it's very easy. Pick all the prime factors with, pick all the prime factors actually with the highest powers. So how would you get the LCM for this one now? You have to pick the prime factors with the highest exponent. So if you want to pick 2, for instance, do not pick this 2, pick the one with the highest exponent, that's 2 raised to the power 2. And then come to 3. 3, which one has the highest exponent? This one here, 3 raised to the power 3. And then 5, 5 is just there, so we'll just pick what we have for 5. And then when you find the LCM, 2 raised to the power 2 is what? 4. 3 raised to the power 3 is 27. And 5 raised to the power 2 is what? 25. So what is 5 times 25? That's 100. Then times 27, that's what? 2,700. Imagine if you were to list the multiples up to 2,700. Isn't that so much? So that's why we shouldn't just use listing the multiples of numbers as the only way to find the LCM of numbers. This is also a very good approach to finding the LCM of numbers. Hope to see you in the next video. Bye for now.